Welcome to Spring LIB.
So to find out the angular acceleration, to find out the torque, we'll be using the equation which relates torque with angular acceleration and moment of inertia. So where I is the moment of inertia and alpha is the angular acceleration. Now, to find out alpha, we know that alpha should be equal to W minus W0 divided by t, where w is the final velocity, which is 1200 reps per minute, and w0 is the initial velocity, which is 0. So alpha, if we convert this to radians per second and calculate alpha, then we can calculate torque. So torque is again moment of inertia. In our case, it's half of mr squared, where m is 2.8 kg and r is 0.1 meter. So we take a square and then we convert 1200 reps per minute to radians per second, and the way we do that is the following. So let me move this aside. Let me put it here. All right. So we have pi radians per second, which is 30 rev per minute. And then we divide that by 2.5 seconds. Now the way we got that is we know that 1 rev is 2 pi radians, and so that means pi radians per second is 30 rev per minute. So we just substituted this guy over here. Right, so from here we get the torque as 0.704 Newton meter. For part B, we need to figure out the angle. Now for the angle, we need to consider the average angular speed of the system. Now we know that the final angular speed is 1200 rev per minute, but the initial is 0. So the average, we call it WAV, will be 600 revs per minute. So W average delta T will be 600 reps per minute times 2.5 seconds divided by 60 seconds per minute. So we converted that to seconds, and that gives us 25.0 rev, which is 157 radians. For part C, where we need to find out the work done, we know that work done is tau times delta theta, where theta is the angle. So that's going to be 0.704 Newton meter times 157 radians. So that gives us 111 joules. Finally, for the kinetic energy, we know that kinetic energy is half of I. That's an equal sign. Half of I omega squared. So that's half of I is, I is half of 2.8 kg. Then for radius it's 0.1 meter. Then we put a square multiplied by 1200 rev per minute, and we do the same thing. We convert that to radians per second. So that's going to be pi radians per second divided by 30 rev per minute, and then we put a square altogether. So let me bring that a little closer here. There we go. It'll be here. There it is. So yeah, let's write that a bit clearly. So this is 30 revs per minute, and then we put a square, and then we finish the square bracket or parenthesis. Right, and that gives us the kinetic energy as 111 joules. So as we can see here that the kinetic energy and this work done are the same, so which relates the work energy theorem. Since the grinding wheel has only kinetic energy, there's no potential energy, that's why all the energies is nothing but the work done. Thank you.